And then that's it. We're not doing anything else with it. We're just rewriting it. Yes, this is that easy. We just got to remember how to write it. Log base 3 of 81 is equal to 4. So that's our log. We want to rewrite that as an exponential. So the base would be 3 to the equals log base 1/2 to the 32 is equal to -5. So throw some fractions in there, negative numbers in there. What's the base? What's the exponent? 1/2 to the -5 power is 32. That's true. Log base 3 of 1/9 is equal to -2. What's the base? Exponent? Only thing left is 1/9. It's got to be equal to 1/9. 3 to the -2 power is 1/9. Still true. Okay. So far they've had the base written there every single time. When that base is not written there, it's an understood 10. Okay, the reason being is we work in the base 10 number system, that we've got a ones position, a tens position, a hundreds position, 1,000, 10,000. So it's base 10 that we live in as far as numbers go in society here with regular math. Okay, so when it's log with nothing written there, it's an understood 10 base. They won't write it there, but it's there. Okay, so when I rewrite that as an exponential, it would be what? 10 to the equals, and 10 to the third power is 1,000. That doesn't change. Still a true statement. What regular log, like that's not there, that's just log. That's called a common log. And it's common enough that it's got its own button on your calculator. Hold on, just want to go this way. It's worked all day till now. I think it's a conspiracy. Common logs are logs that are used pretty often, and we've got the log button, that's log base 10 here on your calculator. Right below that is the next common log, and that's the natural log, and they use LN to denote that natural log. LN of 148.413 equals 5. The natural log is log base E, and E is the exponential number. E to the first power is like 2.714 something. It's a decimal. It's kind of like pi, and that E represents a number. It's a never-ending decimal number, like pi is. Okay, so E is the exponential number, is what we refer to it as. But natural log is the way that we call that. Natural log is log base E. So this rewrites as E to the fifth power is 148.413. That's obviously a rounded value. If you think about E being a never-ending decimal, so it's got to end somewhere. We just rounded it out of that to get there. So natural log is a common log. those common logs will be handy when we go to solve equations in that last section that we'll do. We'll use common logs quite often to solve those, just because it makes it turn out real nice and easy when we do that. So natural log, it's log base e. All right. Now, let's go the other direction, and let's take an exponential statement and write it as a log statement. So write the exponential as a logarithm. 5 to the third power equals 125. So if I'm going to rewrite that as a log, what's the base? 5. So that's going to mean it's going to be log base 5. What's the exponent? 3. So that's what goes over there. Where's the 125 go? The only other place it could be, right there inside of the log. So it's log base 5 of 125 is equal to 3. We're rewriting an exponential as a logarithmic expression. You don't have to. I just do that out of habit, I guess. Because sometimes when we get a little further along, there'll be like x plus 2 or something in there, and then I usually do put that in parentheses. I guess I get the habit of doing that. You don't have to, though. 6 squared equals, what's 6 squared? 36, right? So log base what? Of 36 is equal to 2. It is that easy, guys. And yes, we'll take a quiz over this. It should be 100 for most of us. What's 10 to the 5th power? 100,000. So what log do we use? Yeah, just plain log for log base 10 of 100,000 should be equal to what? Don't. It's kind of like the 1 in front of the x. You just don't write it. You write x equals a number. You don't write 1x equals a number. So don't. I think that'll help avoid some confusion later on. E to the first power equals 2.71. What log do we use? So E is the base, so that'd be natural log ln of 2.71 equal to 1. Thank you. Excuse me. All right. So rewriting as exponentials or as logarithms, back and forth between those two. That's a handy skill. It's going to help us when we go to solve some equations, because some of them, if you rewrite them as exponentials, then the equation is really easy to solve. And then others, if you rewrite them as a logarithmic expression, then the equation is really easy to solve based on what it's written as. So it's just being able to move back and forth between the forms. Okay, so let's work on the next skill in this section. Evaluate without a calculator. This is easy, guys. Don't jump out of the boat yet. Log base 4 of 16. So they would give you this expression and say evaluate that without a calculator. And so what you're thinking here is, okay, what base 4 gets me 16. So the way that I think about this, this one's pretty easy to get. It should be 2. But the way I think about it is I say, okay, well, that's equal to x. Okay, and if I set it up as that, then I can rewrite that as an exponential. 4 to what power is equal to 16? And then I think, okay, 16 is actually 4 what? 4 squared. If 4 to the x equals 4 squared, then what does x have to be? 2. So that means the log base 4 of 16 has to be equal to 2. 2 is the final answer. That's what we're looking for. We created the equation. They're going to give you a problem. It's not going to be an equation. You're creating the equation by saying, okay, this is equal to something. And then I'm going to use what I know about exponentials and logarithms to work it out. Okay. All right, let's look at this one. Log base 2 of 32. And some of you may know your powers. But for those of us that don't know them, we're going to work it out step by step. Okay. So I don't know, maybe I don't know much about 32. But I do know that this problem is equal to something. That it's 2 to the x is equal to 32. Just changing that logarithmic statement into an exponential. Well, look at the base over here. The base becomes a 2. So what I'm going to try to do is rewrite 32. Oh, what do I know about 32? I know it's 8 times 4. Right? Isn't that right? 8 times 4 is 32. I hope it still is. And that's 4 times 2. And that's 2 times 2. And this 4 is 2 and 2. How many 2's does that end up being? 1, 2, 3, 4, 5. So 32 is really 2 to the 5th power. And then here we are back to like the previous example. What does it have to equal? 5. So this must have equaled 5. Log base 2 of 32 must have been 5. Okay. This can be typed in on the calculator. I'm not trying to pull wool over your eyes. But when it's not got just numbers in it, we need to be able to think about rewriting it, okay? Because when we got the variables mixed in, when we get to the equations, if we don't remember how to do this, we're going to struggle with those, okay? So that's why I'm trying to do it without a calculator here. We're going to have some that you're going to do with a calculator, no question. Okay, so let's do a couple more without the calculator, and then we'll do a few with the calculator. Log base 3 of 27. So if I set that equal to x, and then rewrite it as an exponential, it'd be 3 to the x power is equal to 27. What do we know about 27? It's 9 times 3. And it turns out that 27 turns into 3 to the 3rd power. So that means x has got to be equal to 3. And we've evaluated this without a calculator. Let's do a tough one. All right, so there's the original problem. And we want to evaluate that. It's got an x in it. This is where doing it without the calculator is important. Okay. I'm just going to pick another variable. I'll call it n, just for no reason. Okay, just picking another variable. All right. So that would be 2 to some power is equal to 16 to the 3x. What do I know about 16? It's 4 and 4. It's 2 to what power? 2 to the 4th power. But all of that's still to the 3x. What is the exponent rule for that right there? What do you do with those exponents? You multiply them. So that would be 2 to the 12x. So log base 2 of 16 to the 3x is really 12x. That it could simplify to be 12x. It's really what it boils down to. And that's where we'll head. When we get into solving, that's where these kind of rules are going to come back when we do the solving. Okay? This was the original problem. We broke down that side to get the bases the same. And then this 16 turned into 2 to the 4th power. 4 times 3x is 12x. So 2 to the, this is 2 to the n, this is 2 to the 12x, so that must be 12x. So n represented all of this original thing, so that must be equal to 12x. What's going on there? You won't have too many of those in this section. You're more of the number ones, but that's kind of the one of the reasons you want to be able to do it without a calculator there. All right. Let's look at doing it with the calculator, the different bases and how you can type that into the calculator and get a different base and get that to work out. So we're going to evaluate with the calculator. If you need a calculator, they're on the desk there. All right, and we're going to round to the nearest thousandths. So how many places is that? Thousandths is how many places? 3. Okay. And usually, if you're doing these with a calculator, they're not going to work out as good, nice, clean numbers. So we might have log base 2 of 12, and we want to get that answer. If it was log base 2 of 16, we could actually do that without a calculator. But because 12 doesn't turn into 2 to a power or 2 to a nice integer power, that's where being able to do it with the calculator is handy. So on your calculator, to get that base 2, because we've got some log buttons, but we don't have a log base 2. We got a log base 10 and a log base E. But your graphing calculator will do log base 2s. Yes, ma'am. What's on the screen there doesn't matter. I'm just pointing to the buttons right now. Okay? Because that's not the graph that you need. That's one of them we were reviewing for. You'll see. All right, so we want to do log base 2. So to get the log base, you're going to press the math button, the one right under the green alpha button. And then we want to do log base. And we do that by pressing up. So under the first math menu, press the up arrow or alpha A, whichever one you want to use there. So I'm pressing up and I'm going to get log base and hit enter. And it should bring up where you can type in a base and then something else. That's what it should bring up on the calculator. If it doesn't, let me know. We may need to update your calculator if you don't have one rented from us. So we're doing log base 2. So I'm going to put the 2 there at the base and then press the right arrow key and that'll move it over to the next spot. And then we're going to use a 12 there. And just hit enter. And it'll evaluate. 2 to what power gets me 12? 2 to that power gets you 12. Rounding to the nearest thousandths. So that'd be 3.585. Okay. Log base 1/3 of 28. We'll get a decimal approximation for that. If that were 27 there, we could do that without a calculator, but because that's 27 and 1/3 are related with 3. But 1/3 and 28 are not related really well. So with the calculator, we're going to do that log base thing again. Math, log base, and then in the bottom box, I'm going to put 1 divided by 3 for 1/3, and then 28 in the top box, and hit enter. And it cranks out a negative. It's a little bit further away from 0 than -3 would have been. If it was 27, it would have been just plain on -3, but it's 28, so it's -3.00 or 033. So rounding rules. Remember, you look at the number after what you want to stop at. If it was a 5 or bigger, this would go up. That's a 1, so it stays the same. Easy stuff. Let's do PQ log 16. What base is that? So do I have to use the log base button? Or do I have a button that does log base 10? I have a button that does log base 10. So I can just hit log 16. Because that's log base 10. And then just round it to the right spot. If you did, for some reason, forget and go and hit math and go log base, and then you typed in the 10 and then the 16, you'd get the exact same answer. Okay, but you don't have to go through all of that button pushing when you got a log base 10. One more. Natural log of 6. Natural log of 6. Do we have a button for that? Yeah, it's nice. Natural log of 6. Round it to the right spot, be 1.792. And that is it for section 4. Chapter 7. Really is that easy, okay? Because you didn't have the exponent rules. Just a second. Stop.